Good day guys, in this video I'll be teaching you how to download and install CodeBlocks on your PC for writing C language. So first up, go to Chrome browser and search for CodeBlocks.exe download. Then you see this link that says codeblocks.org/download. You click here, then click on download the binary release. So if you're on a Mac OS, you click here. If you're on a Linux, you click here. If you're on a Windows, you click here. So for the sake of this tutorial, I'm on a Windows. So you come here and download this third one here. This one. No, sorry. Download this one here. This. Yeah. I'll put the link to this particular download link in the description. So yeah, this is where I downloaded CodeBlocks IDE. So here it is, just 105 MB. So I'll pause the video now and play back when it's done downloading. So here it is, I've downloaded CodeBlocks. So I'm going to be opening it now. So how to create a new project in CodeBlocks? You can either click on this button here, which is create a new project, and then you click on custom application, then you press go, or you come at the top here, click on file, then click on new, then click on project. So from here you click on console application, then click on go, then you press next, and you choose C here because it's C language you want to use. Then here you put your project title. For me, I'm going to be putting test 1. So just press next and click on finish. So if your program doesn't load in this screen here, this screen right here, just come to this left hand side under projects, workspace, test 1, then open this drop down for sources, click on this plus icon, then click on your main.c. So this is what you are going to see. So this program is basically the program for writing hello world on your screen, for displaying hello world on your screen. These are the preprocessor directives, #include stdio.h and #include stdlib.h. But for this program, they are not really necessary. Then you have your int main, which is the main function for C program. You have the opening curly braces and the closing curly braces, and then we told the program to print hello world on our screen and then return 0. So if you want to run this, at this top, you see this icon for run, then you see build and run, or you can come to this build, then click on build and run, which are the shortcuts for F9. So I'm going to be pressing F9 now, and it has run successfully hello world on the screen. So we can as well remove this stdio.h because we are not inputting anything to the screen, and still build and run our program. It still prints. We can as well also remove this stdlib.h because to print hello world is no, we don't need those two. And also build and run, and it's displayed on our screen also. So this is the first program in C. You can as well leave them alone. #include stdio.h, #include stdlib.h, then your int main function. Because any C program, like I said in my book that I recommend you guys to get, the main function is a function of C where your compiler reads. So anything outside this main function is not going to run. Let's take for instance, let me put this printf outside this place now. It's going to generate an error because this particular program is not in a function, is not in the main function, and is not even in a function that I can call in this main function. So everything your compiler reads in C program is everything inside of this main function. So from the opening of these curly braces here down to the end here is what your compiler reads. So if I build and run this one now, you're seeing it at the bottom here. It says expected declaration specifier or blah blah blah. It's generating an error, and it is flagging this line 9 because I have my printf function there which is not meant to be. So running this one now is going to run successfully because there's nothing outside my main function that wasn't referred to in the main function. So we can as well print another thing. So let me just modify this program and say printf my name My name is Vicol, Olawade. So from here, you can build, click on build and run, or just use shortcut F9. So you have your output here. My name is Vicol Olawade. So in my book, I talked of something called escape sequence, which are the horizontal tab, the vertical tab, the new line, the backslash, and all. It's in the book that you can go there to read. So I just want to show you what they are for. If I output this out now, you're going to see it shows my name is Olawade, and it starts from this line here from the beginning of the screen. And if I also use the new line sequence, new line, the /n is a escape sequence for new line. So if I run this now, it's going to put a new line before printing my name is Vicol Olawade. So let me build and run. And here you see there's a space at the top, which signifies a new line. So if I add like 2 more /n, if I add 2 more, it means I'm going to be putting a first line, a second new line, and a third new line before I actually print my name is Vicol Olawade. So here if I build and run this, you see this is the first line, second line, third line, and then it jumps to this fourth line to write my name is Vicol Olawade. So on and on you can use those escape sequence. You can also use the horizontal tab, which is /t. So if I run this now, you're going to see it's going to indent some paragraph to this program. You see it? This is for the forward. This is for the horizontal tab. It indented space from here down to this place and then prints my name is Vicol Olawade. I can also as well put more than 1. I can put 2, put 3, and then let me close my program. And then I can click build and run. You see, this is the first tab, the second, the third, and then my name is Vicol Olawade. These are just basic things you can do in C. For strings, these are just printing things to the screen of the computer. So let's start with variables in C programming. So more to printing just text like this, we can also print numbers. I can put a number here, 34, but this number is going to be printing as a string, not as a number. I explained in my book there what strings are, what numbers are, characters and all. So this is a number in human sense, but to the computer it is a string. So as this is here, I can't do anything like summation for this with another number because this here is appearing as a string. So to use numbers, you can initialize them, you can declare them as variables, which I'm going to be teaching now. So variables are just abstract storage that stores values for your program. So if you want to create a variable now, I'll first have to specify the data type. If the variable is an integer, I'll use int. Let me say int name, then equals, then I'm going to give it whatever I want to give it, the name, the value of whatever it is. So okay, let me just put a template. Let me say alphabet equals C, then I'll terminate. So this particular program here is to declare and initialize a variable with name alphabet. So what you first need to do, this is char. You can't declare an alphabet C char as an integer. So this is char. I'm telling my program that I want to declare a character variable, and this is name of the variable alphabet, and this is the value. So I explained in my book there that for character variables you can only store one value. That's why you only have C. And for character variables you can only use the single quotes. You can't use the double quotes to initialize character variable. So if I want to come here and print whatever I have in my character alphabet, I'll just tell the program to print F, and here I'm going to specify the format of what I want to print, which is %C. It's in the book there. I explained in the book what format specifiers are. So I'll be printing alphabet. So let me just explain this program again. This is declaration and initialization. I'm declaring this variable alphabet as a character, and I'm also telling my program to initialize the value to C, meaning whenever I want to use this character alphabet, whenever I want to use this variable alphabet, it's be giving me this character C. So now for printing, I'm telling my program to print a character. This is the format specifier, like to specify the data type of the data type of the variable you want to print out. So the data type of the variable is a character. So I'm telling my program to print out a character data type, which is variable alphabet. Do you understand? So yeah, if you run this program, build and run, I'm going to see my result is C. Now, according to what I was telling you, I said you can only use the single quote for character variables, and only just one alphabet can be inside of your character. So if I want to try to add, let's say, another alphabet, which is A, and I save and I run this program, I'm going to see it's going to generate just A. It displays the C because it's only one character it can display at a time. You get your capture data type can only display one character at a time. So if I continue adding whatever, it's this last digit, which is H, that is going to display here after printing it. So you can run this again, and then you see it's just H that is printing. So that is for creating the character variable. Now on this character variable and the string, this is character data type and the string data type. Do you understand? So both of them are declared using the char data type. But if you want to print a string, like I want to print this whole thing, okay, let me say my car is a nice ride. So I want to print this to the screen using this character variable, using this character data type and variable alphabet. If I build and run this, it's just going to echo E. Like only E is going to be printed to the screen, like you can see here. So what I'm going to do if I want to print a string data type is I would first of all change this variable alphabet, and I'm going to put a square bracket in front, opening and closing square bracket. So this here is already telling my program that I want to print a length of character like an array. I'm printing this alphabet like an array with no specified size. So the difference between the character and the string data type is that you're going to also specify both of them as char, but if you are printing a single character, you just need to put the name of the variable. But if you are printing a string character, you need to put this opening and closing square bracket, and then you change your single quote to double quote, your single quote here to double quote. So you open and close a string value with a double quote, and then you are going to give the variable name a square bracket in front. So if I want to print this here, I'll put a square bracket here also, and I'll build and run this. Sorry, this is not going to be there. Okay, I'm going to use %s. The format specifier for string, yeah, I said it in my book there. It's %s, not %c, sorry. So I'm going to be printing this now to the screen. Let's use build and run. Sorry. Build and run. And here you go. My car is a nice ride, as you can see. So the difference between, let me see, car alphabet equals C. The difference between this first and this second one is that this is a character variable that is going to store just one character, which is C, and it is in a single quote. So the difference between a string and a character variable is that the character variable is going to be stored in single quotes, while the string is stored in double quotes. And the character variable can only accommodate just one value in it, while the string can accommodate more than one value, even with spaces and other escape sequence. And the character variable, if you are declaring your variable name can be anything for the character variable, but for the character data type, but the string data type is going to be the variable name plus square brackets in front, as you can see like this. Then printing a character variable is going to be %c as the format specifier, and for string is going to be %s for the format specifier of string. So this is the difference between this alphabet and this alphabet. So that is all for string and char today. Let's do for integer data type. So if you want to print integer data type, just like I'm following these procedures, I can say I'll start with int, which is the data type of my variable. Let me name my variable number, then I'll equal it to something. So let's say 13. So what this means is I have a variable called number. It is an integer data type, and the value is 13. Do you get? Integer is my variable. This is my variable name. This is my variable value. But for integers, you don't use single or double quotes because they are numbers. They are not text. They are not strings. So for integer data type, the values are not going to be in any form of quotes. Just write the values there as they are. So the format specifier for printing integer is passing D. It's in my book also. Then you're going to put a comma and specify the name of the variable, which is number. So these things are explained in the book though. So you want to build and run this program. Let me comment this out. So if you want to build and run this program now, you're going to see output is 13. Meaning, I told this print f here, say okay, print an integer data type which is %d. I'm telling it print an integer data type which has a variable name of number. So I can have another integer data type here. Say int number 2 equals let's say 26. So if I run this program, what I'm printing here is just the number variable. I'm not printing this number 2. So here it should still print just 13. Our output is still 13. But here if I now change it to null and say okay, I want to print the number 2, it means I'm printing an integer data type which is %d as the format specifier, which the variable name is number 2. So running this now, it's going to fetch 26 as the output, as you can see. So that is for integer. And what integers are numbers that are normal counting numbers, 1, 2, 3, 4, 5, 6 and on. You can have decimals to int data type. So if I'm going to put let's say 13.5 here and 26.3 here, if I want to print num2, I'm meant to have 26.3. That's what I want as my output. But this is an integer data type. Your computer is not seeing anything from this point upward, because we are concerned with just the counting number in front, which is 26. Even if I have 10826.3, as long as it is decimal and it is an integer data type, your computer does not see anything after the decimal. So if I want to run this now, build and run, you see the answer is just 10826. It didn't add the 0.3. So this is also an example of logical error. I explained in the book also. This is an example of logical error. You have you initialize your variable to have the value of 10826.3, and then you want to add these two numbers together. Adding these two numbers together, you want to have an answer that will say something like something 0.8. But because you are using integer data type, your computer is not seeing this 0.5, neither is it seeing this 0.3. So if your computer is meant to add these two numbers together, it will displace this point and just give you the addition of 13 and 10826. Do you understand what I'm saying? It's just going to give you. Let's try it out. So let me see. Int add is equals to number plus number 2. Yeah, this is for adding numbers. Just I want to see. I'm giving this data type int to my add variable, and the add variable is going to store the addition of number and number 2. So this is just simple addition in C programming. So now if I want to display the result of add, let me build and run now. You see the answer is 10839. We are not having anything like 0.8. So it can also be logical error, because a programmer might be expecting, oh, I'm going to be having 108 blah 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 0.8, which it did not give you. So for integer data type, your variable and their value, the value of a variable is not going to have anything like points. If you're having points, then you're going to be having logical errors, because the computer is not seeing anything after the decimal point. No matter how much your decimal point is, even if I add more numbers here, if I build and run, it's still going to give me my previous answer, 10839. It's not concerned with the decimal. So that is for integer data type. Your values must not have points. It must not be decimal points. You must have just these normal counting numbers for integer data type. So what if we want to do this kind of calculation and we want the computer to calculate something like this? So let me go back to my 13.6 and this. So I have 13.6 and 10826.3. So if I actually want to do this calculation with the decimal, I have to change the data type. So for data type that can accept floating point number is called float. or you can use double. I'm going to use it now. So this is float. So what you need to do is to initialize your, you have to declare your variable as a floating point data type. You get, so you're going to say float number equals 13.6. So this we are telling your program that is a variable called number, which is a float data type, and because it's a float data type, you can accept values that have points. You're also saying number 2 is going to be a floating point, a float data type, which can also accept a decimal point number. So when you're adding these two numbers together, if you're going to be using int, you're still going to be having the error because your integer add is not a floating point number. Now let me explain. Now let's try to run this program now. I'm going to see what happens. Build and run. So we still get the 10839. It's not showing the decimal point. Why it's not showing the decimal point is because even though your computer saw this 0.6 here at this point of the program, so your computer saw this 0.3. But now your results, where you're storing the value of the addition of the two number is an integer data type. So that means if this adds these two numbers together and you have your 10 something 0.9, because it is an integer data type and you want to print it out here, it's going to displace the 0.9 it already calculated. So in order to avoid that, your result is also going to be a float data type. So if I put float here, so I'm telling my program that there's a variable called add. My value is going to be a floating point variable, the value, and add is going to be equal to what? The summation of number and number 2. So now let's build and run this program, and then you will see that we will have, sorry, what's this? Then build and run, and then you see, sorry, okay, add equals number plus number 2. Yeah, okay, yeah. So what actually happened again now is I forgot to change my format specifier. So now I'm printing a floating point number. In the book I explained there for floating point number, the format specifier is %f. So I'm printing floating point number, you need to change the format specifier. It was %d there before, and that was why it showed that it didn't calculate what we wanted. See, it was showing 5368, which is not what we want, because the format specifier is very, very wrong. So for printing a floating point number, your format specifier is going to be %f. So putting %f here with this variable add, we want to print variable add, which is a floating point number. So just come to build and run, and here we go. We have our numbers 10839.899 blah blah blah, which is this. So you can also use the double data type. I'll say double. It's just like floats, but it stores more numbers. It stores longer numbers than floats. It's in the book explained. So yeah, you can also use double, but for double we have to use capital L F. So I'm going to build and run this, and here we have it, and this is more accurate. If you check the result of the previous one, it was 10839.89 something, but this is 10839.9. Do you understand? This is 10839.9. So this is how you can print double, floating point number, integers, and everything. So we've covered all the data types, and we also did a little bit of calculation. So I'll see you guys in the next video. Thank you. And note, everything we did today was inside of this main function, like I always say. Int main. Everything I'm going to do is going to be inside of this int main. So if I carry these programs and put them outside this int main function, it's going to generate a lot of errors. As you can see, error 1, 2, 3, 4, 5. Everything I'm going to be doing in this program is going to be inside of this main function, because your compiler is going to read anything from this beginning of this curly braces to the end of this curly braces. So thank you very much guys for watching. I'll see you in the next video.